When dealing with linear graphs, finding the gradient is quite easy because if we have the equation, then we can read the gradient off the equation. And because the gradient is constant, which means it's the same at every point on that line, then there is only one gradient. However, when we're dealing with polynomials, so anything bigger than x to the power of 1, the gradient will change at different points on that curve. So let's have a look here at y equal to, or f of x equal to x squared. So we're looking at this one here. Now the curve is there in front of you, you can see that, and we have got 2 points on that curve, P and Q. Now I'm going to just call this point here x1 and that y1, and I'm going to call this x2 and y2. And so you can see there that we've drawn a line between P and Q. We call that a chord. Okay, it is a chord. It's a straight line joining 2 points on a curve. And if I wanted to find the gradient of that particular chord, it would just be y2 minus y1, because remember it's a straight line, over x2 minus x1. And so if we have a look here, our y2 value is a plus h all squared. So let's come over here, because that's where this has come from. This is y2 minus y1 over x2 minus x1. All right, and so when we work all that out, we end up with 2a plus h. So that is the rule for the gradient at any point on that curve. Now, if we have a look at what these values were. This was a, and this is a plus h. So to get from P to Q, we have gone across h. All right, so a is here and a plus h is here. So the difference is h. So if we make our h value approach 0, so in other words, letting it equal 0, because the closer it gets to 0, it's just about 0, we end up with 2a, which means that the gradient of our graph is equal to 2a at the point P, only at point P, okay? So the rule was 2a plus h, but at point P, the gradient is 2a. So in this example, we have to consider the gradient of the chord QP and then find the gradient of the line x squared minus 2x, which is, in actual fact, this graph here anyway, at the point Q with coordinates 3, 3. So we're looking at that graph, x squared minus 2x, and we are going to find the gradient of the chord. Okay, the chord, remember, is the line that joins those 2 points. So we've got this chord going through here. All right, so how do we go about doing that? Well, let's find the gradient first. Remember, the gradient of the chord, PQ, it's just y2 minus y1 over x2 minus x1. And it doesn't matter what you call y2 and y1 as long as you are consistent. So you can see here that our x1 and y1, okay, and this is our x2 and this is our y2. All right. So let's put that into our rule there. So y2 minus y1 would be 3 plus h all squared minus 2 outside of 3 plus h. And we're going to take away y1, which is 3. that is all over, okay, what's it all over? It is all over x2, which is 3 plus h, take away x1, which is 3. And let's tidy that up. So the first thing to do there is to expand out your brackets up the top. Okay, so we know that 3 plus h all squared is 9 plus 6h plus h squared. So we have to remember a few things from previous topics. Now let's tidy that up. So tidying that up, 9 take away 6 take away 3, it's gone. You're left with 6h take away 2h up the top, which is 4h, plus h squared, and down the bottom the 3's cancel out and you're left with h. Now the last thing that I would do there is take out h up the top, and I've got 4 plus h over h, and of course the h's now cancel out and you're just left with 4 plus h. So what I have found there is the gradient of the chord QP. Now the next bit of the question says find the gradient of y equal to x squared minus 2x at the point Q. So remember, Q is this point here. Okay, it's this point here with coordinates 3, 3. So if this coordinate here for x is 3 plus h, and this one is 3, what have you done? You've added h on to this particular coordinate. So the distance between the vertical distance, if you like, is a distance of h. So what about if we let our h value tend toward 0? Let's make h move towards 0, which basically means let h equal 0. Because as it moves towards 0, it's basically becoming 0. So let's substitute that into our gradient for PQ, which was 4 plus h. Now that's the gradient for PQ, isn't it? But what we want is the gradient at Q. So the gradient at Q, okay, the gradient at Q is when we let h equal to 0. So if we let h equal to 0 there, the gradient at Q would be equal to 4. And we know Q is the point 3, 3. So at point Q, okay, so that's the point Q, which is the coordinate 3, 3. The gradient there is equal to 4. All right, so in this question, we're asked to find the gradient of the chord PQ again, and hence the derivative of x squared plus x. Remember, another word for derivative is gradient. So we're looking for the gradient of the graph of x squared plus x. So again, I've drawn the line through PQ, or the chord through PQ, and I know that the gradient of the line PQ is, again, y2 minus y1 over x2 minus x1. So let's nominate our x2 and x1. So you can see here again that this is our x value and this is our x plus h value. We've actually moved up h units to get to that x value. So what am I going to nominate as my y1 and y2, x1 and x2? So doesn't really matter again. I'm going to say that's x1. So that must be y1, and that's going to be x2. That has to be y2. All right, so let's do that. So y2 is x plus h all squared plus x minus h. Take away y1, which is, and I'm going to take away the whole thing, so I'm putting it in a bracket, x squared plus x all over All right, and it's going to be x2, which is x plus h. Take away x1, which is x. And again, that needs to be tidied up. So in tidying that up, you expand out x plus h all squared, which is x squared plus 2xh. And then we've got plus x minus h. And then don't forget this minus sign outside the bracket changes the signs inside. So minus x squared minus x all over x plus h minus x. So let's tidy that up again. So you can see there that we have quite a few things on the top row that cancel out, the x squareds and the x's, and down the bottom the x's cancel each other out. Now the last step here would be to take out a common factor up the top of h, and you're left with 2x plus h minus 1 all over h. And of course the h's now can cancel each other out. And so you're left with the gradient of the chord PQ being 2x plus h minus 1. All right, so that is the gradient of the chord. And therefore, that is nearly the derivative of x squared plus x. The derivative of x squared plus x, we now have to let h move towards 0. Which pretty much means we have to let h equal 0, because when you're finding the derivative of a curve, it is the gradient at a point on that curve. So it's the ability to find the gradient at a point. So letting h move towards 0 in our answer to the gradient of PQ. So if h is equal to 0, then the derivative is 2x minus 1, because h is now equal to 0. In example 3, we don't actually have the graph drawn for us, but we should all know what x cubed looks like. So for those of us who have forgotten, we've got x cubed. We have the point x, which is just somewhere on the x-axis. So that's the coordinate x, and it's on the graph f of x. And then we have our other point, which has moved up h places. It's at x plus h. So this was the point Q, and this one here is the point P, and we're told that that's at x plus h and f of x plus h. Now the question says, for that curve x cubed, find the derivative of x cubed. So we know that this is going to be x1 and y1, and this is going to be x2 and y2. The only thing is here, what we need to find out is, well, we know that f of x is equal to x cubed, but what does f of x plus h equal? Well, wherever you've got the x, you're going to put the x plus h. So it's just x plus h cubed. So let's find the gradient of that chord PQ. So remember, the gradient of the chord is y2 minus y1 over x2 minus x1. So there you go. All right, so we have all this information. We know our y2 value is f of x plus h, and we've just worked that out to be x plus h all cubed, minus our y1 value, which was f of x, and that's x cubed, and that is all divided by x2, which is x plus h, and take away x1, which is just x. And we need to tidy that. So hopefully we've remembered how to expand something, a bracket to the power of 3. So it is the first term squared, so it's x cubed, plus 3 times the first term squared times the second, gives us 3x squared h, plus 3 times the first term times the second term squared, which gives us 3xh squared, and then it is the last term cubed. Don't forget the minus x cubed on the end. And then down the bottom, x plus h minus x. Okay, let's tidy that up. So tidying that up, our x cubes disappear up the top and our x's disappear down the bottom. And so we're left with that. But of course we can take out our common factor now, which is h, and we're left with 3x squared plus 3x h plus h squared all over h. And of course now our h's will cancel down. And we're left with that bit inside the bracket. Now the last step there is to let the bit inside the bracket, let the h move towards 0. Because remember, we want the gradient at a point. So we're going to let our h value move towards 0. So we're going to let it equal 0. And if we let our h value equal 0 in there, then we are really only left with 3x squared, because the rest is plus 0 plus 0. So our final answer there is 3x squared. Let's look at the final example here. Not so lengthy, these ones. What we're asked to do is find the limit. So in the questions above, we've been letting h approach 0. This is what we're actually being asked to do here. The limit as h approaches 0, we're looking for the value of this, basically, as that h is equal to 0. So you should always factorise first if you can. So if you're looking at this one, 2x squared plus 40xh plus h, is there anything common to that whole expression? And the answer is no. So now is the time that you can let h approach 0 or h equal to 0, and you are quite simply left with 2x squared, because plus 0 plus 0. Same thing with this one, but of course with this one you can see that we can take out a common factor of h up the top. So I'm going to do that. So it's going to be h, and left inside the bracket is 4x squared plus 3h, and that is all over h. All right, and now the h's will cancel out. And as I let my h tend towards 0, so the limit as h tends towards 0 would be, again letting my h value equal 0, and would be equal to 4x squared. All right, with the next one, again, I'm letting h tend towards 0, but there's no h in this. So quite simply, my answer here is just 5x. There's no h to let equal 0. And the last one as well, there is no x and there's no h. So as I can't let h tend towards 0, then I'm just looking at what my limit is approaching, and it is approaching 3. So in the next exercise, we're actually going to look at how to do this a lot more quickly than what we've been doing in this exercise.